So you've got a pretty good introduction already about what Manufacturing USA institutes are all about. So very simply, our public-private partnership was created to improve U.S. manufacturing competitiveness through the use of robotics. That problem is directly tied to the workforce issue in this country today, where it's two fundamental issues. One is there's a skills gap, the other is there's a supply problem. If you go out and talk to manufacturers everywhere, they will tell you that they can't hire enough people and they can't find enough qualified people. So we're working in both of those areas. We fund projects on the technology side and on the workforce side. Fundamentally, though, more importantly, I think for this group here is that we are a tech transfer organization. It doesn't do us any good to create the next greatest technology or workforce program if we can't get it into practice. Right now, we have about 20 people on our staff. We've been in business just over 2 years. Most of our people are tech transfer experts. So if you want to partner, we'd love to talk to you. More on that later. We do have a membership category just for federal labs. We already have several in our mix. So I'm going to talk a little bit about the problem that we're solving and how we solve it, and a little bit about what's going on in the industry. I'm going to skip over a couple of slides real quick because, interestingly enough, you've seen them already this morning. Anyway, so we have a particular focus on small and medium-sized manufacturers. A lot of the larger companies in this country are already well down the robotics adoption process, as well as working very actively at solving their workforce problems. But these are some of the key things. They just don't understand the technology, when to invest, what to do, what are the capabilities. It's changing very rapidly, and how do they keep up with it? So drivers of adoption of technology is that in this country right now, people are making things that weren't necessarily made here before, and we're not losing as many industries as we did in the past. But as one of my colleagues says, that if you could only buy what's made in the United States, you'd be naked, sitting on the ground, and unable to communicate. In that we don't really make clothing and furniture here like we used to, and we've never really made cell phones or computers. So we're working in all of those spaces to try to either reclaim or not lose industries. But the wage gap isn't as great as it used to be. American workers are some of the most productive in the world, and the energy position that we have right now, as well as the regulatory environment, is making manufacturing a lot more competitive within the boundaries of the United States. We really are at an inflection point. You're familiar with, often people use the term Industry 4.0. I prefer the Fourth Industrial Revolution. And in Pittsburgh, we're kind of headquartered where the first two industrial revolutions took place in this country. And so we're really focused on the use of data and intelligence in the manufacturing world, not just the other Manufacturing USA institutes, but we in the robotics industry. It's very critical to where we are. There's a lot of things that have changed just in the last few years to make robots more accessible, higher performance, and in fact, quite more economical. Technology is converging. You can see on this chart where everything is changing, and it's also creating a pretty significant workforce problem. You can't just come right out of high school and go into most factories any longer. You can't come right out of high school and go into a coal mine any longer either. You're not really digging coal, you're operating a very expensive piece of machinery. The same thing is happening in many US manufacturing sites today. We don't encourage people to not go to college, but trade schools right now can very quickly prepare people at a much lower cost for a pretty great career path. If you study the right things and are able to work alongside a robot because of the skills that you have, that is a great way to have a really solid investment in a secure career. Anyway, so as I mentioned already, I think twice before, the convergence of technology and talent. Adopting advanced technologies in manufacturing isn't really possible unless you have the people to do it. Technology isn't really replacing people, it's enabling people to be more productive, and it's enabling businesses to be more productive. One of the things that we are seeing, which is an odd effect here, is that because of the shortage of workers, people that own and operate businesses are accelerating their adoption of robotic technologies because they just can't find the workers. But robots aren't really replacing workers, they're assisting workers. If you have a job right now that is easily replaceable by a robot or an AI system, you probably don't have a very interesting job. But training yourself to work side by side with these technologies is where workforces are going in the future. There is a real, I mentioned a very great human case for robotics. The two biggest industries in the United States that have invested in robotics are logistics and automotive. In the last 10 years, their workforces have dramatically increased because they become more competitive. And suffice it to say that if you're a business owner or operator and you're not doing everything you can to improve your cost, quality, and schedule performance, by definition, you're going out of business. So it's important, to stay focused on investing in technologies as well as your own workforce development. And those are some of the things that we're trying to stimulate. And again, it's tied directly to workforce development issues, investing in technologies. So, as we look at the future of manufacturing, I mentioned briefly earlier that robots aren't replacing people, they're replacing specific tasks. Robots, they still don't do what you see in the movies. There's a big difference right now between artificial intelligence and artificial general intelligence. If you watch a lot of sci-fi movies, we're not there yet, we may never get there. But what robots do really well is precise, repetitive tasks. And those are things that we as people don't necessarily do that well. We get tired, we get distracted. Robots don't get tired, they don't get distracted. Anyway, so it is increasing manufacturing productivity as well as workforce productivity when deployed properly, and we try to help people to do that the right way. So some of the keys to adoption, robots do need to become more versatile. A lot of the robots deployed in the last 30, 40 years are really only capable of doing one thing, mostly carrying a spot welder to a very specific point on the side of a car. But they are becoming more versatile and fungible, if you will, usable in different tasks. Time to deploy and repurpose is coming down dramatically. Cost of ownership, I mentioned, workforce readiness. Technology adoption is becoming a lot faster as we learn more about that as a discipline across all industries. Forgive me for turning to the side. It's the only way I can see the slides. We have done a lot of work in this space on technology adoption, specifically within the robot world. I used to work in a federal lab, this 5-step process. You've all seen it before. We work to apply these things to our manufacturing clients as well. Moving along, you've seen this slide twice now. We all use it. We're part of that group. Our membership is much like Haresh's. We have 197 members as of 4 o'clock yesterday. We have 9 different membership categories, from large companies to nonprofits to universities and federal labs. We'd love to have federal labs. There's no fee to join. You don't have a cost share obligation. It all comes under our TIA with the Department of Defense. But if you'd like to talk to us, you can catch the information on the website, or more importantly, just send me an email and we can talk about it. We invest in technology development, workforce development, and our national ecosystem. We have basically 9 hubs that we're creating around the country for technology deployment, and these are usually made up of an MEP, a university, and a couple of companies that have decided to band together to work on projects. This isn't our total membership, it's just some concentrated areas, and we think we have pretty good coverage across the United States for our ecosystem. Our members are located all over the United States, West Coast, South quite a few in the Northeast, in the Pittsburgh and the Boston areas, which tend to be hubs of robotics activities. Seen this slide before. This is just a cross-section of our membership. We have large companies, aerospace companies, a lot of startups in the robotics field, most of the top universities in the robotics field, and our home base is at Carnegie Mellon University. We are co-located with the Manufacturing Futures Institute at CMU, where we'll be in 2 months when we move into our brand new facility, which has a lot of extra room in it if you want to get set up with us and CMU. The Manufacturing Futures initiative at Carnegie Mellon is focused primarily in additive manufacturing, which is a really nice adjunct to what we're doing. You've seen this slide before. We invest in TRLs 4 to 7 on the tech side, and more or less, if you could put that on the workforce side, it would be the same thing. We then work to mature the technologies and move them into a transitionable form. Our process is a standard 2-step process of concept paper. It's evaluated then by teams of our members as well as ourselves and our government team. Then we invite you to provide a full proposal, and that's either accepted or rejected, and we fund. Tech side tends to be around $500,000 for 1 year. On the workforce side, it's more like $250,000 for 1 year. And that's basically the process. We are undergoing an experiment this summer to remove one of these steps. That would be the concept paper step. We want to try to accelerate everything. We're trying to get much, much faster to time to market, and so we're working with our government team to try to accelerate the proposal process. These are the key areas at a very broad level where we invest in technology. De-risking for transition to the factory floor, cobotics, human-robot interaction, interoperability, flexible retooling, and intelligent robotic systems. The introduction of the future of robotics is all about artificial intelligence, so we're moving that way like everybody else is. On the workforce side, the problems are generally very well known. The education system doesn't quite fit the needs of the manufacturing world. There's a negative impression of manufacturing. There's significant differences regionally in this country. Not enough workers in many places. In some places, unfortunately, there's too many. But anyway, we're working across the board. We're investing in some programs right now to bring underrepresented populations into the workforce. Women in particular, we have several programs going in that space. 50% of the workforce is women, but only 23% of the manufacturing workforce is. This is our first set of projects. It's an eye chart. I'm sorry about that. This is the first 18. We're launching 12 more in the next 6 weeks. We're doing lots of cool things. We're sorting fish. We are sanding helicopter rotor blades. We're building wiring harnesses. We're working with flexible materials. We're building cobotic applications that are being deployed in car companies right now. And we've got a whole new list of things coming down the pike, as well as a bunch of new workforce programs we're going to be launching this summer as well. So we're working across the board. We hope to have some of these set up in our building when we get there in June of this year for demonstration and further development. Anyway, that's me, that's us. Thank you for listening. I'm going to turn it back over to David for some questions.